Hey everyone, Mr. Mayor here. In this video we will prove lines parallel, and by the end of the video you want to be able to say I can prove two lines parallel using a two-column proof. We're just going to look at one example here. So our directions, we need to use a two-column proof to prove the following is true, and we're given that angle 5 plus the measure of angle 7 is 180, and the same with angle 6 plus the measure of angle 5 is also 180. Our job is to prove that K is parallel to M. Now, again, every time we look at this, Mr. Mayor, this looks like they're going to be parallel. It's great. But our job is to prove so using the types of angle properties that we've learned throughout this unit. So we're going to go ahead and get started. Just a step, I want to make sure that you remember every time you every time you write something in your proof, you want to make sure that you label it in your diagram as well. Draw it in if there's congruent angles or whatever. It really helps you visualize what's going on, what's true, so that you can use that to help you in your next step of your proof. All right, so to get started, hopefully you remember we always want to start off our table, our two-column proof, with the given information. Looks like we've already got two pieces that we can enter in right here. So that is number one. And how did I know that this is true? I know because this is my given information. Okay, same thing with the second given. And you don't always have to put givens back to back. Sometimes if the first given is helpful to knowing something else, then you can go ahead and add that as well. But so far at this point, I've got both givens and we are good to go. So nothing really to mark. There's not a symbol for angles that add up to 180, supplementary angles. So we're just going to go ahead and leave the diagram as it is, no big deal. So now what we're going to do is we're going to look and we're going to say, is this information helpful maybe either to the diagram or is it helpful to each other? Well, what I'm noticing right now is that angle 7 plus angle 5 is 180, same with angle 6 plus angle 5 is 180. So what I'm noticing is these things, they're similar, they're not exactly the same. I know I have 5 in both of those, but I do see that both of them equal the same exact value. Since they both equal 180, what I can say is that this thing, 7 plus 5, has to also be equal to 6 plus 5. Because again, if both angles equal 180, if both pairs of angles equal 180, then they have to be equal to each other. Okay, so what I'm doing here is I'm taking this information and I'm plugging it right in. I'm plugging it right in to this spot of 180. Because remember, if 6 plus 5 equals 180, then I'm just going to put it in 180's place, and now they can be equal to each other as well. Okay, so I'm plugging it in. Do you remember? Let's see if you remember your properties. When I plug something into math, that is called substitution. Okay, so I use substitution in order to make the first two pair of angles equal to the second pair of angles. Now, you are noticing something here. It's always step by step. What can I use in the previous step to help me with the next step? Well, take a look. Angle 7 plus 5 equals angle 6 plus angle 5. So I'm noticing right now that there is something repeated on both sides. So I can say, oh wow, there's a 5 here, there's a 5 here. What if I just went ahead and subtracted the measure of this angle 5 to both sides? What is going to happen? What am I going to be left with if I subtract the measure of angle 5 to both sides? Hopefully you're seeing once I subtract angle 5 to both sides, you're going to be left with the fact that angle 6 is equal to angle 7. Okay, so I subtracted 5 to both sides, and now I'm starting to see some of these relationships. So take a look. Like, if I look at angle 7 and angle 6, think about it. This is always what you want to train your brain to do. What is the purpose? Do I know something about those two angles to each other? Well, those two angles are corresponding. If corresponding angles are congruent, then you're starting to realize, oh wow, yeah, if corresponding angles are congruent, then those lines have to be parallel. So in order to get this step, what I did is I just subtracted 5 from both sides, and it's literally called the subtraction property of equality. Okay, so that's where we are right now. So now I'm noticing, again, this train of thought that we used. Since angle 7 is now equal to angle 6, I'm starting to realize, well, if the measures are the same, I also know that they're going to have to be congruent. Now, this is kind of an extra step that everyone forgets about, but what this property, what we are trying to do is we're trying to say, since 7 and 6 are corresponding angles, I need to know that they're congruent in order for the lines to be parallel to each other. Well, I just had that they were equal. So now I need to go ahead and say that they're also congruent. If they're equal, then they're congruent. There's a simple little property that lets me say that. Anytime that two things are equal, they are also congruent. That is called the definition of congruence. Okay, so this is widely used. Get used to this one. It's going to be everywhere. Anytime you want to go from an equal sign to a congruent sign. Last step. Now I know. Now I'm ready to mark my diagram. I said 7 is congruent to 6. Let's go ahead and put that in the diagram. 7 is congruent to 6. Hey, this is exactly what we've learned. 7 is congruent to 6. These are corresponding angles. If corresponding angles are congruent, we have something called the converse of the corresponding angles theorem. That's going to say that your lines must be parallel. So last but not least, I already know. This is it. We're finished. Line K has to be parallel to line M, and the reason for that is because we use the converse of the corresponding angles theorem. Okay? Thank you guys for tuning in. Hope to see you soon.